Hello, all my wonderful people out there. Welcome back to another geometry lesson. Today we are doing 6-4, which is all about proving whether or not a quadrilateral is a parallelogram. So here, we're going to be able to demonstrate whether or not a quadrilateral is a parallelogram based on the sides and the diagonals. And then we're also going to look based on the angles. There's no new vocabulary today, and there's no new theorems or properties or anything. So we're actually going to get right into this. One thing I do want to point out is that we are kind of going to jump around here a little bit, and we are going to be skipping some of these problems. So just be aware of that. So like, for example, we're not going to do example 1, but we are going to do this try it. Okay, so this says, explain why you cannot conclude that ABCD is a parallelogram. So remember, properties of a parallelogram, if I draw a wonderful little parallelogram here. Properties of a parallelogram, opposite sides are parallel and congruent. So those two sides are parallel and congruent. These two sides are parallel and congruent. And then consecutive angles add to 180. So this is angle 1, 2, 3, and 4. So consecutive angles add to 180. So like 1 and 2 add to 180, or 1 and 4 add to 180. And opposite angles are congruent, so they are the same. So when I look here at this shape, what I need to show is, right, in order for this to be a parallelogram, opposite sides have to be congruent and parallel. So if I look here, AB is opposite DC. Not only are these sides not parallel, but they are not congruent. Okay, so I can say that opposite sides are not congruent. If the opposite sides are not congruent, it cannot be a parallelogram. So the opposite sides are not congruent or parallel, either one. So ABCD is not a parallelogram, right? So I conclude that it is not a parallelogram because the opposite sides are not parallel and they're not congruent. Okay, so just kind of using logic there to figure out why that cannot be a parallelogram. Example 2 says that Tio sketches a design of a quadrilateral shaped building. Here it is right here. If 1 is supplementary to 2 and 1 is supplementary to 4, is his design a parallelogram? Okay, so let's look here. If angle 1 and angle 2 are supplementary, right? That means they add to 180. And here, if I look, they are same side interior. Remember, I'm going to draw a little diagram here for you. Remember, same side interior angles are angles that are inside two lines caused by a transversal. So they're inside two lines. So these are same side interior, and they're supplementary. So since they are same side interior and supplementary, that tells me that the top and bottom are parallel, because the only time same side interior angles add to 180 is in parallel lines. So that tells me that this line and this line are parallel. Okay? So that's dealing with 1 and 2. So I know these top two are parallel, so it's at least a trapezoid. Then I'm told that 1 is supplementary to 4. So angle 1 and angle 4 are also could be same side interior, right? If we're looking at these two lines, right? And this line can be same side interior. So same side interior. And they are supplementary because it tells me in the problem that they are supplementary. Only time same side interior add to 180 is in parallel lines. So the sides are parallel. So again, these two sides are parallel. So is this a parallelogram? Are opposite sides parallel? Yes, yes. So it's a parallelogram. Okay, we can use that same idea for B, but we're not going to. Okay, we're gonna keep a cruising down here on the triads. Okay, so I want you guys to try these two. Is DEFG a parallelogram? Explain. And is LMNO a parallelogram? Explain. So remember, in a parallelogram, consecutive angles add to 180. Opposite angles are congruent. So use those two facts to see if these two quadrilaterals are parallelograms. And when you're ready to check your work, you can go ahead and hit play on the video and we'll go over it. Okay, so let's review our work here. So for the first one, I see that I have 3 out of my 4 angles. Knowing that the sum of all 4 angles here is 360, right? Because it's a 4-sided shape. I can find that this the fourth angle is 27. So do I know that these two, or this shape is a parallelogram? And the answer here is yes, right? Because opposite angles are congruent and consecutive angles are supplementary. So not only are opposite angles congruent, but consecutive angles are supplementary. It has to be both. Just because consecutive angles are supplementary does not mean it's a parallelogram. You have to have both consecutive angles supplementary and opposite angles are congruent. Okay, for B, is LMNO a parallelogram? No, it is not. Even though 89 and 91 are supplementary, 89 and 89 are not supplementary. 91 and 91 are not supplementary. So no, consecutive angles are not supplementary. And I'm going to abbreviate supplementary. And right, opposite angles are not congruent. 89 is not congruent to 91. So opposite angles are not congruent. Okay, so it has to be both. You have to be able to have both. All right, let's look at example 3. Example 3 says, for what values of R and S is WXYZ a parallelogram? Okay, so in order for it to be a parallelogram, opposite sides have to be equal, right? So that tells me that S plus 5, be very careful with your S's and your 5s because they look pretty much identical, right? Is equal to 2S minus 2. Those two sides would have to be equal. So I'm going to solve. I'm going to minus s. I get 5 is equal to s minus 2 plus 2 plus 2. 7 equals s. So there is the value of s that I would have to have in order for this to be a parallelogram. Also, 4r plus 7 would have to equal 7r plus 1. So I minus 4r minus 4r. 7 is equal to 3r plus 1 minus 1 minus 1. 6 is equal to 3r. So r would have to be 2. So not only would s have to be 7, r would have to be 2. Okay? And then b is very, very similar. What values of a and b is RSTU a parallelogram? So I know that opposite sides have to be equal. Or excuse me, opposite angles have to be equal, right? I could do something with consecutive sides adding to 180. The only problem is consecutive angles adding to 180. The only problem is that then I would have an A and a B. And that's just pretty hard to solve. Okay, so we're just going to stick with B and B and A and A. Okay, so I'm going to set opposite angles equal. So 4B plus 1 has to equal 3B plus 37. I'm going to minus my 3B, minus my 3B, and I get B plus 1 equals 37, minus 1, minus 1. B would have to equal 36. And that would make angle R and angle T congruent. But I also need angle S and angle U to be congruent. So I have to set those equal to each other as well. So 5A equals 3A plus 14 minus 3A minus 3A. So 2A equals 14. Right, divide by 2, A would be 7. Okay, so in order for RSTU to be a parallelogram, B would have to be 36 and A would have to be 7. Hopefully that makes sense. You guys have a try it here. Go ahead and pause the video. I really do want you to try this. Here it gives you an X value of 25, a Y value of 30, and it wants to know, is this a parallelogram? So we can just plug in our numbers and figure it out. Then same thing, B says G is 14, H is 5. Is this a parallelogram? So you're just going to plug in your numbers and find out. So go ahead, pause the video, do the work, and then when you're ready to review it, hit play. All right, so let's look here. Here I'm given X is 25. So right here I'm going to plug in 25. 2 times 25 is 50, minus 10 is 40. So this right here is 40 degrees. 40 degrees, there we go. Here, X is 25, so 25 plus 15 is also 40. So far, opposite angles are congruent, so that's a good sign. I'm also told that Y is 30, so if I plug in 30 here, 5 times 30 is 150, minus 10 is 140. And over here, 3 times 30 is 90, plus 50 is 140. So opposite angles are congruent, so that's good. Then we need to check, does 40 and 140 add to 180? Are they supplementary? And they are. So PQRS is a parallelogram. Okay, so yes, PQRS is a parallelogram. Because, don't forget to always put your reason, because opposite angles are congruent and consecutive angles are supplementary. Abbreviating some words there, right? So opposite angles are congruent and consecutive angles are supplementary. So this is a parallelogram. Okay, similar for B, right? G is 14, H is 5. So let's plug it in. 2 times G, G is 14. So 2 times 14 is 28, minus 11 is 17. So BA is 17. CD is 14 plus 3, which is also 17. So right now, opposite sides are equal. Okay, then up here I have BC. H is 5. So H plus 1, 5 plus 1 is 6. And down here I have 2 times 5, which is 10, minus 3, which is 7. So opposite sides are not congruent here. So this is no. ABCD is not a parallelogram. Oops, I didn't put a space. Is not a parallelogram because opposite sides are not congruent. 6 and 7 obviously are not the same length, so the opposite sides are not congruent. So this is not a parallelogram. We are going to skip example 4 here, which is the proof. And we're going to go on to this try it. So something that I want us to remember is that in a parallelogram, the diagonals bisect each other. So they cut each other in half perfectly. Okay, so for like this try it, when it's asking is ABCD a parallelogram, I'm going to call this maybe point E. That means that B to E and D to E need to be the same length. Okay, so if this is going to be a parallelogram, 7p plus 1 has to equal 5p plus 3. And I'm going to solve. So I subtract 5p, subtract 5p, and I get 2p plus 1 equals 3. Minus 1, 2p equals 2, divide by 2, so I get p equals 1. So p would have to be 1 in order for this to be a parallelogram. Also then, A to E and C to E would have to be the same length. So that means that 3q plus 1 would have to equal 2q plus 3. So I'm going to solve minus 2q minus 2q, and I get q plus 1 equals 3. Minus 1, q would have to be 2. So in order for this to be a parallelogram, p would have to be 1 and q would have to be 2. Okay, so I want you guys to try this one. And as we always need to fill in the information we know. We know that A to E is x plus 2. I know that B to E is 2. C to E is 2x minus 2. And DE is x minus 2. And it says, for what value of x is ABCD a parallelogram? So go ahead and hit pause on the video, give this a shot, solve for x, and then when you're ready to review it, hit play. Okay, so let's look this over. There's actually 2 different equations that you can set up here, and either way you did it is perfectly fine. I'm going to do it both ways, but you should get the same answer no matter what. Okay, so the first way is that A to E has to be the same length as C to E. So that means that x plus 2 has to equal 2x minus 2. Right? They have to be the same length. So I'm going to solve this for x. Minus x minus x I have 2 is equal to x minus 2. Add 2, and I get 4 equals x. So that's one way that you could have done it. Another way that you could have done it is setting BE equal to DE. So setting 2 equal to x minus 2. And here's a lot shorter. I just add 2, and I get 4 equals x. So either way you did it is perfectly fine, but you should get 4 both times. Hopefully that's making sense. We're going to go ahead and look at example 5 here. Okay, so example 5 is saying, is PQRS a parallelogram? Explain. Okay, so I am given that opposite sides are congruent, and I'm given this 48 and 32. Well, what's special about 48 and 132, is that if I add them together, I get 180. So that tells me that, and I'll write this, because angle Q plus angle R equals 180, they are same side interior. So that means that QP is parallel to RS. So that means that these lines, not only are they congruent, but they're also parallel. Since they're parallel, right, I can say that opposite sides are congruent and parallel. So because of that, yes, it's a parallelogram. Parallelogram. Okay, for B, is WXYZ a parallelogram? Okay, so the only thing I know about this shape is that the line XZ is cut in half. I know nothing about WY. I don't know if that's cut in half. I don't know anything about these angles. I don't know anything about the sides. So there's really just not enough information. So we just say no, not enough info. Right? So you have to have enough information to prove that it's a parallelogram. So let's look at the triads. I want you guys to try these 3. There we go, I didn't fit them all. Just asking if it's a parallelogram, and if it is, why. So go through, try to figure out as much information about it as you can, and then when you're ready to go over it, hit play, and we'll go through each of them. Okay, so let's look these over. Is ABCD a parallelogram? Well, I know that A and C are congruent, so I know that one pair of opposite angles are congruent. I don't know anything about BD, and I know nothing about the sides or anything like that. So this is not enough information. So no, not enough info. For B, is EFGH a parallelogram? Explain. So 29 and 151 are supplementary. Those do add to 180. So angle E and angle F are supplementary. So what that means is that side FG is parallel to side EF. So these are also parallel. Okay? Since they are parallel, that means that these two angles, H and G, are also supplementary. So this is enough information to say, yes, EFGH is a parallelogram. And then the last one here, I'm going to fill in what we know. We know angle 2 is 52. I know that angle B is 135. I know that angle C is 52. So remember that the sum, right, the sum of all these angles, all four of the angles, has to be 360. Okay, so I can add them all up, solve. But what I end up finding is that 52 plus 135 does not equal 180. So even though these two angles are opposite or congruent, A and B consecutive angles are not supplementary. So this is a no. And the reason is that consecutive angles are not supplementary. So this cannot be a parallelogram. Okay. All right, guys, so we have one problem left here. Example 5, and then I try it. So here it says, a mechanic raises a truck using a lift. For safety, the floor must be horizontal, obviously, and the top of the lift must be parallel to the floor. Otherwise, the truck would roll off in one direction or the other. So it says, is the lift shown in a safe position? Explain. Okay, so I know a couple things here. I know, oh, we can't see that. I'm going to redraw this. Let's draw it up here, just so you can see me manipulating it a little bit better. Okay, so I know that this is 6 and this is 6, so I can say that those two are congruent. I also can say 75 plus 105, those are supplementary. So since those are same side interior, since those are same side interior, I know that these two sides are parallel. Okay. So I can say that those two sides are parallel. That means that this angle here and this angle here must also be supplementary, which means that these two sides are also parallel. So is the lift shown in a safe position? Yes, because the top or the lift and the floor are parallel to each other. And it says explain. So we can say, let's say same side interior angles are supplementary. So since that 105 and that 75 are supplementary, I can say that the left and right sides are parallel. Ooh. Okay, since the left and right sides are parallel, that means the top and bottom are parallel. So the top and bottom are also parallel. And they are congruent. So is this lift safe? Yes, it is, because the top and the bottom are parallel. Okay, similar idea for this last problem here, the try it. It says a carpenter builds the table shown. If the floor is level, how likely is it that a ball placed on the table will roll off? Right, so I want to know if I put a ball up here on the top, will it roll off the table? Right, if it's parallel, if the top of the table is parallel to the floor, that ball should not roll off. But if the top of the table is tilted or is not parallel to the floor, the ball will roll off in one direction or the other. So I want you to think about this, look at the information that you're given, and decide if this ball is going to roll off the table or not. All right, so let's look. Will the ball roll off the table? So I need to look at the information I'm given. I have two diagonals here. I see that one diagonal is split in half because half of it is 10 and the other half is 10, right? So it's split in half. The other diagonal is also split in half because one half is 20 and the other half is 20. So that tells me that the diagonals bisect, cut in two, right? Bisect each other. Since the diagonals bisect each other, the table is a parallelogram. And that is just by definition. Okay, so since the table is a parallelogram, that tells me that the tabletop and the floor are parallel to each other. So the table top and floor are parallel. So since the tabletop and the floor are parallel, if I put a ball on the top, will it move? Right? It's not tilted in either direction, so that ball should not move. Okay, so the ball won't roll off the table. So this whole section is really just about taking those properties of a parallelogram and using them to determine whether or not a shape is a parallelogram. So you're given a shape and you're just said, hey, is this a parallelogram? And we have to use those properties. As always, if you need help or if you have any questions, make sure that you reach out and we'll see you guys next video.